In this work, we have studied the characteristics of gallium nitride grown on mica substrates. Gallium nitride is a wide bandgap semiconductor suitable for ultraviolet devices. We have studied the polarity, the strain, and also the strain relaxation through the formation of telephone cord buckles. And this is a work done between the Institute of Material Science of the University of Valencia and the group of Bruno Dodin from the CEA in Grenoble, France. The samples we have studied are grown by plasma-assisted molecular beam epitaxy on mica. The growth temperature ranges from 850 to 800 degrees, and the main change between the samples is the flux ratio between the gallium and nitrogen atoms. The most singular of the samples is this one, sample B, that has a larger gallium ratio. In order to study the samples, we have used Raman spectroscopy. Through Raman spectroscopy, we analyze the samples through the characteristics of the vibrations of their components. And in particular, in these samples, we find two modes, TO, which is associated with the zinc blende phase, and E2H, which is associated to the Wurtzite phase. In sample A, we find different regions, and in the different regions, we have seen differences in the ratio between Wurtzite phase and zinc blende phase, and also differences in strain. We can evaluate the strain by determining the frequency of the different modes. In sample B, we find a predominance of the zinc blende phase. This is important because it is very difficult to grow zinc blende phase materials, which has several advantages over the Wurtzite material. And here we see that the sample is more homogeneous. It has also a compressive strain of around minus 0.2%. And finally, sample C was very similar to sample A, although more homogeneous. We have also studied using atomic force microscopy and Kelvin probe force microscopy. We have studied the topography of the samples and their electrical characteristics. Since the samples are inhomogeneous, we have first selected from sample A a region where we find in one part, which is part 1, we know that we have a mixture between zinc blende and Wurtzite phase, while in part 2 we have the dominance of the zinc blende phase. And then we have characterized these parts by Kelvin probe force microscopy, and we find that the contact potential difference reflects this composition. In region 1, we have a mixture of two different phases, the yellow one and the blue one. And in part 2, it is more homogeneous. We have more everything like the blue part. The blue part means low contact potential difference. Yellow part means higher contact potential difference. And when we analyze these pictures in more detail, we find that the zinc blende phase is related to a contact potential difference of 850 millivolt, while the Wurtzite phase is related to 900 millivolt. And this 900 millivolt we can associate with nitrogen polarity for the Wurtzite phase. Concerning the zinc blende phase, it is the first time that this is measured, so we had to compare it with other techniques, and in particular this assignation was corroborated by CBD patterns. Finally, we have studied the formation of telephone cord buckles on the surface. These are delaminations that have the shape of a worm, like this one seen here in this optical micrograph with this worm shape. And from the geometrical characteristics of these worms and their comparison with theoretical simulations, we can extract different parameters of the sample. This is an AFM picture, and this is the comparison with the simulations. And we have obtained different parameters. The work of addition, which is here. We also determine the square root of the ratio between the film residual strain and the critical strain, promoting the formation of the telephone cord buckles. And then we can obtain the strain either by the simulation or and compare it with the Raman measurements. And we see that the strain compares quite well with the measurements. Also, the work of addition obtained correlates very well with that of mica over mica. So we assume that it is the mica which is delaminating and forming these worms with the gallium nitride film on top of it. If you want to know more about this work, you can go to this reference here in nanotechnology, which has been just accepted.